Hello, hello. So, hopefully you can hear me well. Today we are going to read the paper Chain of Thought Prompting. So this paper is about obviously chain of thought prompting, which is a popular prompting method used these days. And I want to dive into this paper. Honestly, I think, but this would be a very fast read because a lot of the paper relies on like examples and all. Like, yeah. I mean, maybe not. Yeah, maybe not. The paper is pretty long. So before starting to read the paper, I would like to ensure that the stream is working properly. I mean, maybe not. Yeah, maybe not. Okay, all good. Now, now, okay. Chain of thought prompting, reading. Okay. Now, before I read the paper, uh, let's first start with the abstract. Oh, this is from Google. Really, I didn't know that. Let's go like paper. Yeah. Oh, that's the wrong place. Uh, paper. Again, paper. Reading research papers. Yeah. Fine, fine. Now we'll go 23, which is a chain of thoughts. And we will put you here and like main dot markdown. Yes. Fine. So since this is a very good paper, we are going to read through the whole paper. So we will start with chain of thought again. We explore the how now for those who don't know, chain of thought prompting. I know a bit about chain of thought prompting because it's a popular prompting method. So let's start with this. Um, like Raja has 5 tennis ball, he buys 2 more cans of tennis ball. Each has 3 tennis ball. How many tennis ball does it have? So when you prompt an LLM like this, there is a decent chance that the LLM gets the question wrong. No, it gets it right. But then we ask more, it gets it wrong. Or maybe this is as a part of the prompt. Yeah. Oh, all this is prompt. Okay. So the answer is wrong. But instead of like doing this, we prompt the model to answer in a more elaborate way. This increases the chance of the model getting the answer right. So that is the chain of thought prompting. So we'll start reading. We explore how generating a chain of thought series of intermediate reasonings. We explore how generating a chain of thought series of intermediate reasoning steps significantly improve the ability of large language model to perform complex tasks, complex reasoning. In particular, we show we show how reasoning abilities emerge naturally in sufficiently large language model by the simple method of chain of thought prompting. Reasoning abilities increase also. Where a few chain of thought demonstration provide example in the prompting. Experiment on 3 large language models show the chain of thought prompting improves performance for a range of arithmetic, common sense, and symbolic reasoning tasks. The empirical gains can be striking. For instance, prompting Palm 540B. But it's a Palm 540B is like this like gone, right? They don't exist anymore. Was it? No. Palm 540 billion. Uh no. Pathways language model. With a chain of thought example achieves state of the art accuracy on GSM 8K. I don't know what the benchmark is. Oh yeah, you can copy from this, right? Yeah, that's kind of bad. Oh, grade school math. Cool. Surprising why fine-tuned GPT-3. Nice. Okay. So before we read the intro and all, I'll skip all this. We will start reading these guys. Fine-tuned GPT-3. Prior bust. PAM 540B with standard PAM. Look at the improvement. It is very significant. I start with 5 balls. Multiple choice, common sense. The answer is that there are now one-digit numbers. Oh yeah, you are example of chain of thoughts, right? Input, chain of thought, output. Triple for arithmetic, common sense, or symbolic reasoning. Nice. Hmm. Nice. Language model. We have 5 language model. Okay. I mean, what if I like show me example of chain of thoughts prompting? I think I'll ask this guy. Math problem. Instead of asking what is 15 percentage of, okay, let's ask that. What is 15 percentage of 234? 35.1. What if I ask Google that? 234. Wait, my bad. 234 into 15. My bad. Oh, my bad. Okay. Calculate 15% 234. Please solve step by step. Okay, so initially when the paper was released, it was such that uh, you kind of explain the answer. But these days it is like you ask the LM to explain the answer. Okay. So yeah, I'll write that later after kind of understanding the whole thing. Should I invest in stocks or bonds? Everything through. Okay. Hmm. So what is a complex question? Like 234 into 5.65 divided by 3 plus 56.77 into 5.14. Okay. So if I ask ChatGPT this question, okay, you actually answer it step by step. 4.485, that's correct. What if I ask you this question? So you're also solving this step by step, huh? Okay. The hard raised to uh 2.713. How about now? Oh, what are you doing? 0002 0002. Okay, you got it wrong. But you use a calculator, didn't you? Oh, you used the Python code and ran it, huh? Okay. Now do it step by step, ensuring the answer is correct at each step. Hmm. Does that make any difference? Hmm. Okay. I mean, no, thank you. So probably these guys already implement chain of thought and all like inside when it is made, right? So probably won't have much impact at the moment. It will be impactful on APIs and all. Or at least that's what I think now. So okay. Standard prompting. Prior supervised the best. Chain of thought prompting. Yeah. Oh, this is chain of thought. Huh? Cool. Standard prompting. Equation only. Variable compute. Reasoning after answer. Chain of thought prompting. Yeah. Nice. Okay. Let me. Hmm. What is this checklist? Probably I'll get it once I read it. Freaking because how do I? Why does increasing model scale improve chain of thought prompting? Model scale made by 62 billion language model. Semantic understanding. One sub missing. Other. Hmm. Error fixed by scaling from 62-bit to 540B. Okay, so higher scale models probably are better in what do you call it? Chain of thought. Hmm. Mm-hmm. Prompting. Mm-hmm. This falls on the category of general prompting approaches, whereby the input prompts are optimized to allow a single large language model to perform better on a variety of tasks. Just give me a sec. All right. Okay. Using intermediate reasoning steps has a long history in programming synthesis and execution. Recent work along this direction has included a number of architectural innovations, as well as the use of large language models. The program execution work uh, closest to ours is this one, which shows that large language models can perform up to 10-digit addition. Evaluate polynomial and execute Python programs. Whereas generating a program and then executing can be viewed as a kind of reasoning. Numerical and logical reasoning. Intermediate language setup steps. Correct chain of thought analysis. As mentioned in the main text, we analyzed 50 chain of thought from lambda 137 billion that led to the correct answers in GSM 8K dataset. GSM 8K dataset. Of these 50, only one arrived at the correct answer through incorrect reasoning. The other 49 had correct logic and math. For example, 5 had minor imperfections while maintaining coherent and understandable logic. Okay, cool. We also manually analyzed 50 random sample output of the model that were incorrect on GSM 8K for lambda 175, the 137B. There are many ways the chain of thought can be incorrect, making the design of error categorization non-trivial. We decide to categorize errors into what changes are needed to make the chain of thought correct. Calculation error only. We found that 8% of chain of thought were completely correct except for a calculation error. In other words, applying an external calculated equation as done in something else would make the chain of thought correct. Simple mapping error. We found that 16% of the chain of thought were correct except for what we call mapping errors. We define a simple mapping error. Simple is the final equation the chain of thought. We constrain the category chain of thought. Okay, sure. One step missing error. Okay. Hmm. Oh, that is what is called symbol mapping. You just, instead of 50, you just like 30. Okay, cool. Additional robustness. Sports understanding data set. Full prompt. Oh, oh, this is the prompt you gave, huh? I think they gave all these things. Hmm. Prompt for coin flip. Mhm. Okay. I will start reading a paper. Right? Can I get this thing on? Hmm. Okay. Nice. No. Where prompting method. That what do you call it? It's a prompting method where we describe. Okay, sure. Okay, it increases increase. No. Increases like reasoning, math, thought, etc. Like it's not just increase, it significantly increases. Works better as the LLM scales. Okay, now let's read. Interaction. The NLP landscape has been revolutionized by large language models. The scaling up the language model has been shown to confer a range of benefits such as improved performance and sample efficiency. Scaling up model size alone has not proved sufficient for achieving high performance on challenging tasks such as arithmetic, common sense, and symbolic reasoning. This work explores how reasoning ability of Latin can be unlocked by a simple method motivated by two ideas. First, technique for arithmetic reasoning can be benefited from generating natural language rationals that lead to the final result. Our work has given ability to generate. Second, the language model offer the exciting prospect of in-context future learning via prompting. can include future examples. I mean, I don't need this. What LLM am I using? What happens when you do this? Also, I don't know what it did, but something. That is, instead of fine-tuning a separate language model checkpoint for each test, you can just prompt, okay, sorry, okay. Both of the above ideas, however, have key limitation. For rational argument training and fine-tuning method, it is costly. For traditional future prompting methods, works poorly on tasks that require reasoning abilities and often does not improve substantially with a large language model scale. Okay. In this paper, we compare strength of these two ideas to avoid their limitations. Sure. Specifically, we explore the ability of language models to perform future prompting for reasoning tasks given a prompt that consists of triples. A chain of thought is a series of intermediate language steps. Okay. Okay, thank you. I'll take you. Series of intermediate natural language steps that lead to the final output. Final output. That's better, right? Chain of thought prompting. Consider one thought process. Chain of thought prompting. Hmm. Consider one thought process when solving a complicated task such as multi-step math word problem. It's typical to decompose the problem into intermediate steps and solve each before giving the final answer. The goal of the paper is to endow language model with the ability to generate similar chain of thought. A coherent series of intermediate steps that lead to the final part of the problem. We will show how a sufficiently large language can generate chain of thought. Yeah, it mimics a step-by-step thought process. Allows model to decompose multi-step problem into intermediate steps. Provides an interpretable window into the behavior of the model. That's also true. Searching how it might have arrived. Okay. Third, can be used for tasks such as math word problems. Common sense reasoning. Ready, acted by large of the show. Yeah, sure. Arithmetic reasoning. We begin by considering math problems, math word problems, which measure the arithmetic reasoning capability of the model. Though simple for humans, arithmetic reasoning is a task where language model often struggle. Yeah. For the baseline, we consider future prompting popularized by Brown. Huh, what happened? I think it's alright, right? Okay, let's go like future prompting paper. Now, future prompting paper. Brown. Okay. Okay. China prompting. Our proposed approach is to augment each example of a short prompting with a chain of thought for the associated answer. Also, the dataset have only evaluation split. We manually compose of a set of 8 few short examples with chains of thoughts in the prompting. Okay, cool. 5 LLMs. ChatGPT, Lambda, Palm, this thing, and Codex. Result. The strongest result of chain of thought prompting was summarized in figure 4. Hmm. Model scale. Result. Smaller model doesn't show much difference. Yeah. Larger models show large, I mean, not necessarily. There's a difference. Decent at least. Sometimes very, very much. Oh no. The three takeaways. First, figure first of the chain of the prompting is an emergent ability of the model scale. That is, chain of thought prompting does not positively impact performance for small model and only yields performance gain when used on models very bigger models. Okay, you can be like green. We qualitatively found that the model of smaller scale produces fluent but illogical chain of thoughts, leading to lower performance than standard prompting. Really nice. Chain of thought has, yeah, lost baseline performance. The performance is almost double. Okay, yeah, yeah. On the other hand, sync of the easiest subset. It's only requires single steps to a performance negative or very small. Like that, sure. Third, chain of thought prompting by GPT-3 compares favorably to the prior state of the art, which typically fine tunes a task specific model. Okay. To better understand China's prompt, we manually examined models. We also randomly examined 50 random samples for which the model gave wrong answers. The summary of the answers were 46 of the chain of thought were almost correct, barring minor mistakes. The 54% of the chain of thought had major errors in semantic understanding or coherence. To provide a small insight into why scaling improves chain of thought ability, we performed a similar analysis on error made by Palm 62, and thus our summary is that scaling Palm 540B fixes a large portion of one step missing and semantic understanding errors. Hmm. Evaluation study. Mm-hmm. Okay. Robustness. Sensitive. Hmm. Okay, then we talk about common sense reasoning. Probably it also increases, which is okay. Symbolic reasoning, which is simple for humans. Oh yeah, things like Amy Brown and you concatenate by an nice and coin flip. Mm. Mm. Odd evaluation, which ends up prompting discussion. We have explored the chain of thought prompting as a simple mechanism for setting multi-step reasoning. We first saw the chain of thought prompting improves performance by a large margin. Yeah. Mm. The emergence of chain of thoughts results as a result of model scale. For many reasoning tasks where standard prompts had a flat scaling curve, chain of thought prompting leads dramatically. Does not answer whether the neural network actual reasoning, which can be left for an open question. Cost of manually augmenting contempla with chain of thought is minimal. The future setting, such annotation could be prohibitive for fine tuning. There is no guarantee for correct reasoning path, which can lead to both correct and incorrect answers. Finally, emerges chain of thought only at large angle might make causes serve in the real world application. Further research could explore how to induce reasoning in small language models. Okay. Conclusion. Oh yeah, that's it. We have explored chain of thought as a simple and broadly applicable method for enhancing reasoning. To the extent in these guys, we find chain of thought reasoning an emerging property of model scale that allows sufficiently large language model to perform reasoning tasks that otherwise have flat scaling curves. Broadening the range of reasoning can perform will hopefully inspire for further works on language models. Nice. That was fast, man. The paper was very fast. I thought so though. Yeah, still have no idea what this thing is. Okay, I guess that's it for today. That was fast. Yeah, I think I'm going to end that here. So thank you for watching. See you soon. Goodbye.